Welcome to 6.2 Solving Radical Equations. Today we are going to solve radical equations algebraically. One thing that we have to reintroduce is extraneous solutions. So these are solutions that we get by correctly simplifying and solving. However, when we plug them back in, they do not satisfy the original equation. So yes, we will be plugging our answers back into the original equation to make sure that they work, because sometimes they will and sometimes they won't. So, some steps for solving radical equations. The first thing you want to do is isolate the radical. Now, if you only have one radical, that's ideal. One radical isolated on one side by itself. However, sometimes you will have two, and generally, my recommendation is to isolate one radical to each side of the equation. It's going to make your life so much easier. Now, once we have isolated the radical, we will be solving for the missing variable, and we do that generally by squaring both sides or cubing both sides to cancel out those radicals. And then we are going to plug our solutions back into the original equation to check for those extraneous solutions. So number one is already set up very nicely for me. I have one radical, it's isolated on the left-hand side. So now I'm going to go in and I'm going to square both sides of the equation. When I square the left side, the radical cancels out, leaving me with -8 minus 2t, and 0 squared is just 0. Going to do some steps for solving. I added 2t to both sides of the equation, and that gave me -4 equals t. I haven't boxed my answer yet because I do need to take this t equals -4, plug it back into the original equation to see if it is correct and true. So when I plug it back in, I end up getting the square root of -8 plus 8, which is the square root of 0, equals 0, which in turn results in 0 equals 0, which is true. So since it's true, I'm going to box my answer because it is a solution. Moving on to number 2. So now I already have my radical isolated on the left-hand side, so I don't need to do any steps there. I'm going to go ahead and go in and square both sides. Again, the square root and the square are going to cancel each other out, and I'm going to end up with p squared on the right-hand side. Now again, anytime you see a square term, a single term, and a number, you should be thinking factoring. So I'm going to try to move everything to one side of the equation. That's going to give me 0 equals p squared minus 7p plus 10. And then I'm going to try to factor. So I'm trying to get something that is going to multiply to be 10, add to be -7. My two factors end up being -5 and -2. And since my a is equal to 1, I can use the shortcut and say that my two factors I would use to split the middle become my written factors. So p minus 2, p minus 5. And when I set each of these factors equal to 0, I get p equals 2 and p equals 5. So I'm going to go ahead and plug both of these into the original equation and see if they hold true. And when I do that, when I plug in 2, it ends up being the square root of 4 is equal to 2, which is true. And then when I plug in 5, it ends up being the square root of 25 is equal to 5, which is true. So both of these are solutions to my equation. For number 3, I'm going to follow a similar method. Now, I do have a little bit more on the right-hand side, but that is okay. As long as your radical is isolated, that is the goal. You want to have it isolated, especially when there's only one. It makes your life easier because if I had something else on this left-hand side, I would have to FOIL. Do not want to have to FOIL with a radical if I don't have to. So I'm going to square both sides, and I would much rather FOIL with x plus 3 than a radical in another term. So remember x plus 3 squared? The squared does not distribute. It is x plus 3 times x plus 3. Square root and the square are going to cancel out. I'm going to FOIL the right-hand side. That gives me x squared plus 6x plus 9. Again, I see a squared term, I see a single x term, I see numbers. I'm going to try to move everything to one side and factor. So I'm trying to get something that multiplies to be -5 and adds to be +4. That's going to give me the factors -1 and 5. Again, a is equal to 1, so I can use this shortcut where I say x minus 1 and x plus 5. When I set each factor equal to 0, I get x equals 1 and x equals -5. Going to take both of these factors, going to plug them into my original equation and see if they work. Well, when I plug in 1, I get the square root of 16, which is equal to 4, so that one is true. When I plug in -5, I get the square root of 4 is equal to -5 plus 3, which is -2. Well, the square root of 4 is +2, and +2 is not equal to -2. So this one is not true, meaning it's an extraneous answer. So what I generally do in my final answer is I just cross out the one that doesn't work and I box the one that does. Now, number 4 starts off a little bit differently. I have a exponent of 1/2. Now remember, anytime I have a fractional exponent, the denominator is going to be my root, my index, and the numerator is the exponent. So anytime I see a fractional exponent of 1/2, it's automatically a square root. So, one other thing, I do want to get the radical isolated by itself. So I also am going to subtract 5 from both sides of the equation, giving me x minus 5 equals the square root of 3x minus 11. Now I'm going to go in and square both sides. Now, again, the reason why I moved the 5 over was because if I don't have to, I do not want to FOIL a radical. I want to avoid that as much as possible. So it's nice to be able to just cancel it out when it's isolated by itself on one side. So again, going to move into factoring, and I'm trying to find something that multiplies to be +36, adds to be -13, which is going to give me, let's see, -9 and -4. A is equal to 1, so I'm going to use the shortcut, x equals 4, x equals 9. Going to plug both of these into my original equation. Now, the 4 does not work because I get -1 is equal to the square root of 1, which a negative is not equal to a positive. However, the 9 does work. I get 4 is equal to the square root of 16. 4 equals 4. So the 4 is canceled out. The x equals 9 is my only solution. For number 5, I am going to, again, try to isolate the radical. So I'm going to add n to both sides of my equation, and I'm going to square both sides. So I'm going to get n squared minus 6n plus 9 is equal to 37 minus 3n. Move everything to one side. Try to find factors that multiply to be -28, add to be -3. My two numbers that do this are 4 and -7. So n is equal to -4, n is equal to 7. Going to plug both of these into the original equation. Now the -4 results in -7 is equal to +7, which is not true. So this is going to be an extraneous solution. And the +7 results in 4 equals 4. So my n equals -4 is an extraneous solution, and my n equals 7 is a solution. So I crossed this one out, and I boxed n equals 7 as my only solution to this problem. Now, number 6 is going to be one of the hardest problems of this type because it is going to require us to square things multiple times. And it's because of the fact that I am dealing with two radicals. I have no option but to FOIL with a radical. So, my first piece of advice, if you have to FOIL with a radical, try to make it so that you're FOILing with a radical and a number. You don't want to have to FOIL with two radicals together. It just complicates things a little too much. So I'm going to go ahead and I'm going to move this square root of y minus 2 to the right-hand side. So I just added it to both sides of my equation. So that leaves me with the square root of 4y plus 1 is equal to 3 plus the square root of y minus 2. Now I'm going to go through my same procedure. I'm going to square both sides of the equation. Now remember, squaring on the right-hand side, I'm going to be FOILing. So I am FOILing with this 3 plus square root of y minus 2. And on the left-hand side, it just canceled out the square root. So I'm going to start with my first. So 3 times 3 is going to give me 9. I'm going to start with my outsides. 3 times square root of y minus 2 is just 3 square roots of y minus 2. Insides results in the same thing, 3 square roots of y minus 2. And my lasts, I'm going to do plus square root of y minus 2 squared because it's the same thing times itself. Now, going to do a little bit of simplification before I start anything else. The left-hand side is just staying the same so far. I added my two middle terms to give me plus 6 square root of y minus 2. And this square root and this squared cancel. So that leaves me with plus y minus 2. Now, anything not attached to the square root, I'm going to move to the left-hand side of the equation. So I'm going to subtract 9, subtract y, and add 2. And that's going to give me 3y minus 6 is equal to 6 square roots of y minus 2. Now, this is where we're going to do another round of squaring both sides. So ideally, if possible, you want to have this be a equals, not a coefficient of 1. So I am going to try to make this 1, and I'm going to try to get this number down as low as I can. And the only number that all three of these terms have in common is 3. So I'm going to go ahead and divide by 3 on both sides of the equation. This is not a necessary step. You can absolutely FOIL with larger numbers. It just makes life a little bit easier because this becomes y minus 2, and I'm only dealing with a coefficient of 2 on the right-hand side. Now I'm going to go back again, and I'm going to square. Now, squaring on the left-hand side is going to be FOILing, which results in y squared minus 4y plus 4. Squaring on the right-hand side, this squared is going to distribute to the coefficient 2 and to the square root. So this coefficient 2, 2 squared, is going to be 4. And when I take the square root of y minus 2 and square it, the square root cancels out, leaving me with y minus 2. This 4 is going to distribute, giving me 4y minus 8. I'm going to move everything to one side, giving me y squared minus 8y plus 12. And from here, now I can normal factor. So I'm looking for something that multiplies to be 12, adds to be negative 8. That's negative 6 and negative 2. Y equals 2. Y equals 6. Almost done. I am going to have to check my answer, so I'm going to plug both into the original equation. And I get 3 equals 3 when I plug in 2. And I get 3 equals 3 when I plug in 6. So both of these work, meaning both are solutions to my equation. For number 7, we have a graph of f of x is equal to the square root of x minus 2 plus 7. That's my red line here because it's a square root function. And g of x is equal to 4. This is my line here, my blue one. And they've been provided. Identify these solutions, if any, to square root of x minus 2 plus 7 equals 4. So where is the solution between these two graphs? Well, I have a square root function. That square root function starts at where the origin has been shifted to. We've gone right 2, we've gone up 7. And nothing else happens on this left-hand side. This doesn't dip down, it doesn't do anything weird. So based on this graph and knowing what a square root function looks like, these two graphs are never going to intersect. And when graphs do not intersect, we say there is no solution. Now, another option you could have taken a look at was looking at the equation. If I were to isolate this radical, I'm going to get Square root of x minus 2 is equal to negative 3. And we've talked about square roots before at length. Square roots cannot equal negative numbers. So, anytime you end up with a problem where you have a square root is equal to a negative number, you can go straight to the conclusion of no solution. Now, if you were to solve it and you were to plug your answers back in and find that all of them are extraneous, you would still say no solution. And you would still get credit. You just did a little bit more work